This is the 13th lecture of the electrostatics. In this lecture, we will discuss about the product of the two vectors. Basically, because we are going to discuss about the electric flux and the other things, also dot product and the cross product. So I think that it should be have a separate lecture to discuss about the some of the properties of the cross product and the dot product. Basically, the product of the two vector is not simple. It is in, you can say, it has a two part. First one, I think you have already know about some of the bit. A dot b, dot product means I simply write it dot product, and the other is, second is simply the cross product. Yes, of the two vector we are discussing about the two vector only. Then it is dot product, and the second is cross product and dot product. Let's suppose you have the a and b vectors. Let's suppose you have the a vector, and let's suppose you have the b vector. Let me write it, because most of the book write this is the a vector, the below is the a vector, and the here the b is this vector. And then, if what do you mean by dot product? It simply means I represent the dot product is by a, simply put the dot here, and then b, and it is nothing but is equal to magnitude of a vector, and into magnitude of the b vector and the cos theta, where the theta is angle between the two vectors, basically angle between the two tails. Okay, remember it is the tail between the angle. We are taking the angle between the two tails of the vectors, and I can simply write it a b cos theta. And what it represent, geometrical interpretation is, it is nothing but, if you take out the, let's suppose this is simply the b. Let me consider this is as the, it is having the magnitude is represented by the this arrow, basically, and the length of the this arrow. And let me take as the b vector. Then what is the projection, and simply what is the component here in the a vector direction? It is nothing but b cos theta. Yes, and simply, if you are not getting, cos theta is nothing but base by hypotenuse. Let me write it, base as b, capital B, and then hypotenuse is nothing but b. Then the base value is come out to be b cos theta. Then I have written this is as the b cos theta. The geometrical interpretation of the a dot b vector is nothing but, it is a geometrical representation. In the geometrical representation, we simply take the, it is the projection. I will write as the a dot b a dot b is the product of the length of the one vector and the length of the projection of the other vector in the direction of the former. It means, simply I write it as the a vector dot b vector is nothing but magnitude of the b vector, projection of a, simply the projection of a vector. You can write in this way also, in the direction of the b. You can, in the direction of the b vector. Okay, and a dot b, b vector and the projection of the a in the direction of the B vector. We simply write it. A dot B is nothing but is equal to B dot A. Then I can simply say that the from the above command, the projection of the B projection of the A vector in the direction of the B, you can also reciprocal this statement. This is also equal projection. Let's suppose I just replace the A B vector by A. You can simply then you can also say that the A vector magnitude of the A vector projection of the B vector in the direction of the A vector. You can also uh, simply say that they basically they are equal. Dot product is equal. A dot B is equal to B dot A, because you can argument is A B cos theta. The if you take because if you change the theta from the minus theta, because in this A dot B and B dot A are equal basically, because if you change the sign of the theta to the minus theta, it is equal. Yes, because it is even function, and simply we say that the cos theta will consume minus sign in it, and they are basically equal. Due to this property only, the A dot B is equal to, if you take let's suppose A vector into B vector is nothing but A B cos theta. If theta is equal to, if theta is equal to 90 degree, then it is 0. Yes, A dot B vector is equal to 0 because the cos 90 degree is 0 simply. Then we simply say that they are independent upon each other, independent upon each other. They can't have any projection over it. Yeah, you can simply say that if you have the these are the basic example, x cap, and let's suppose this is the y cap. They do not have any projection. Any projection, if you want to try to take the projection of the y cap in the x direction, it is nothing but 0. Yes, similarly if you are try to find out the projection z vector, z component in the x direction, this is 0. We simply say that these x y z are linearly independent vectors, uh, linearly independent vectors. Then only the we simply say that the coordinate, these dimensions have the 3 coordinates. Hopefully you will deal with it. The coordinates are nothing but the 3 independent components of the vectors. A dot A is nothing but A square, because the angle between same vector is nothing but 0. Yes, cos theta 0 become 1, and then it come out to be A square. You can also find out the magnitude of the A from the, this is A, sorry, this is the A here, and you can also find out the magnitude. This is nothing but magnitude. Yeah, and then if let's suppose for the simplicity I take the example, let me take out the example to find out the magnitude. Okay, and let me take as 2x cap plus uh, 3y cap plus z cap. And if you want, if somebody says that what is the magnitude, the direct formula is there. This direct formula come out from this only. The direct formula for the finding out the magnitude of the r vector is nothing but the coefficient of x. X is nothing but 2 square, and then coefficient of y is 3 square, simply 3 square, and then 1 square. This come out to be magnitude, and this formula come out to from this equation only. And for this you can take out the magnitude. Magnitude is nothing but let me take first of all dot product. What is, if you have the two vectors, if simply I write it 2x cap plus 3y cap plus z cap plus z cap and dot product with the same vector, and this is nothing but simply you have to multiply the coefficient of the x with the x. Yes, this is nothing but x with the x coefficient multiplication. Simply multiplication 2 into 2 is 4, and 3 into 3 is plus 9, plus 1 into 1. Yes, 1 into 1 and 1 into 1 is 1. This is the method to find out the dot product between the two vectors, and this is nothing but a dot a is nothing but r square. Then if you find out the magnitude of the r vector is nothing but this is magnitude only. Okay, this is another equation. This is nothing but under root of 4 plus 9 plus 1. You are getting same. Yes, this basically this formula come from the this method only, from the taking the dot product. Okay, and why I am not multiplying for this to this? If you can multiply it, no problem, because if you multiply here the x and x cap. Yes, if the x cap cos theta between them, these are the same vector, then the cos theta is 1. Basically theta between these vector x and x cap is 0. If you take out the dot product with the other y cap direction, because x and y are perpendicular to each other, then the cos theta become 0. Basically then this no need to write it, because then it becomes 0. You can also multiply it this way, because x and z also are perpendicular to each other, then dot product is obviously 0 for it. And so there is no need to write this term also, no need to write this term also. These are also perpendicular, y direction is perpendicular to x cap and z cap. For the mutually perpendicular unit vectors, if you have the unit vector x cap, y cap and z vector, it is simply I am simply saying that x cap, if you take the dot product with the y cap, is equal to, can you think of it, x dot z cap plus simply equal to sign, and z cap, if you take the dot product, basically these are perpendicular to each other and the unit vector, then basically the theta cos theta come out to be 0, because they are perpendicular to each other, then the dot product between them is 0. I am simply using this property only to finding out the dot product here. I have also represent telling the same thing here in the to finding out the magnitude of the r cap. Okay, and then here you can also x dot x is equal to y dot y. What is the answer you are getting? Yes, you are getting 1, because the same vectors having the cos theta 1, because they are unit vectors, then their magnitude is 1 only. Yes, unit vector, if you do not know, unit vectors are vectors having the magnitude is 1. Okay, and I simply the unit vector are represented by the cap. It is basically, if the magnitude you find out, the simply magnitude of these unit vector are come out to be 1, because they are unit vector, then only we say the name unit vector. Scalar product of the two vectors is distributive. It is nothing but, let's suppose you have the a vector plus b vector, and you are taking the dot product with the c vector. I can distribute it simply means a vector into c vector plus b vector into dot c vector. And you can also change the position from the first property. You can shuffle these a dot c vector is nothing but c dot a. You can also change the position. Sword inequality. What this inequality says that magnitude of the a dot b vector is always less than, yeah, equal to a vector magnitude into b vector magnitude, because in the a dot b is coming the cos theta. Yes, cos theta value is always, if you take out the magnitude, yes, simply cos theta value is nothing but in between -1 to 1, then only it value is always going to be greater than. Scalar product of the two vectors is distributive. It is nothing but, let's suppose you have the a vector plus b vector, and you are taking the dot product with the c vector. I can distribute it simply means a vector into c vector plus b vector into dot c vector. And you can also change the position from the first property. You can shuffle these a dot c vector is nothing but c dot a. You can also change the position. Sword inequality. What this inequality says that magnitude of the a dot b vector is always less than, yeah, equal to a vector magnitude into b vector magnitude, because in the a dot b is coming the cos theta. Yes, cos theta value is always, if you take out the magnitude, yes, simply cos theta value is nothing but in between -1 to 1, then only it value is always going to be greater than. Yes. The scalar product the two vectors is equal to the sum of the product of their corresponding components. What it means I have already represent. Let me take the one another example also. Let's suppose you have the a vector is represented by x1 x1 x cap plus y1 y cap. Let me write it as, just leave it, z1 z cap, and let me represent the b vector as y, let me, x2 x cap plus y2 y cap plus z2 z cap. If I am taking the dot product is nothing but simply the corresponding element should be multiplied. Yes, I have already illustrated in the previous to find out the magnitude, and this is nothing but dot product with the corresponding element. Just remember it, x1 into x2 plus y1 into y2, simply corresponding element. Yes, remember it, and z1 z2. And in the previous we had discussed this, this only I have, this is nothing but corresponding element I have multiplied. Yes, this also I have multiplied the corresponding elements. Yes, this is the other property, you can simply write it. Yes, the corresponding elements. And okay, this I have taken as the other property, and these are the simple thing. And you can also try with the finding out the angle between them. Let me, angle between the two lines. If you want to find out the angle between the two lines, yeah, the same vector also you can easily find out by taking the taking the, sorry, dot product between them. And let me illustrate it. Let's suppose you want to find out the magnitude between the two vectors. A dot b is nothing but A magnitude into B into cos theta. You can find out the, if you know the dot product between them, then the cos theta is value is come out to be A vector dot B vector, and their magnitude. Yes, you can simply multiply with their magnitude, and then you are getting the cos theta angle between the two. Cross product is simply, let me take the A cross B, they are represented, this is nothing but the A cross B, the cross product between A vector and the B vector, and it is nothing but magnitude of the A, magnitude of the B, and sine theta angle between them. Let me assume that this is the B, this is the A vector, and this is the B vector, and then simply A cross B, A magnitude, B magnitude, and the cos theta. Theta is the angle between the two vectors. Cross product A cross B vector. We have seen the A B cos sine theta. Sorry, and the cross product. If we the after cross producting, we will get the, because the cross product will give the vector quantity, and we have forget this a very important point, for the dot product we get the scalar quantity. Yes, basically we are getting, for the dot product we are getting the, uh, after dot product, after doing the dot product we are getting the scalar quantity, but in the cross product you should get, we are missing out, because after the cross product you will get the vector quantity itself. The after cross producting it, the vector quantity direction is the unit vector perpendicular to this plane. If I have taken the A and B vector in this plane that you are I am writing, and then the unit vector is perpendicular to this n cap vector is the unit vector uh, perpendicular to the surface in the plane we are taking A and B. Basically this out to be n cap is out to be in the outward to the plane, and it come out to be inside the plane. We are going to discuss what is the direction, what is the correct direction. For this, correct direction is outward. Basically, to find out the direction, we are going to the second point, we are going to use the right hand rule. uh, take your fingers of the right hand to the A vector, and just try it. Do your fingers to the A vector, and then try to curl your finger to the B vector, because they are in the same plane. If you curl in the direction of the B vector, then perpendicular to the plane, that the screen that you are looking, the in your direction, the thumb will give the direction of the unit n vector, and it is come out to be, if you look at it, come out to be in the outward direction. Thumb is going telling the direction of the n cap vector, and it come out to be outward to the plane. Yes, and simply then we simply say that it is perpendicular to the plane, and I have written the first point is its direction is perpendicular to the plane of the A and B. And what is the direction of the A cross B vector? It is perpendicular to the plane in which the A and B vector are going to be. The direction is given by the right hand rule, yeah, right hand system, you can say. uh, Simply just look at it, very important point. And geometrical interpretation of the A vector, A vector A cross B vector is nothing but it will give the area of a parallelogram. Area of a parallelogram. Let me show you. Uh, it will give the area of a parallelogram. How should I represent it? Let's suppose you have the uh, a vector, and let me take it. This is the b vector. Then the a cross b is nothing but give the area of this parallelogram, and this is the I have represent. This is the vector resultant of the two vectors, and this area, yes, this whole area, the area of this parallelogram is given by the a cross b vectors. Just remember it. So simple. A cross B property, and the first property is A cross B vector is not equal to B cross A, and simply it should change the sign. It should change the sign. Basically, if the A vector cross B vector is minus of B vector cross A vector, just remember it, because in the cross product we are dealing with the sine theta is not equal to sine minus theta, yes, because it should carry the negative sign. Sine theta is negative of the, if we are considering a negative sign come out to be, yes, basically okay, I should not write in this way. It should be in this way only. It should carry the negative. If it should carry the negative sign, you can also write in this way also, that I rub it out. Yes. Second property. Second property, if you have the parallel vectors, then the cross product is come out to be 0. Yes, because the angle between them is become 0, then the A, let's suppose A dot B vector are parallel to each other, means the A dot B sine theta, theta becomes 0, sine theta becomes 0, then the sine theta is 0 value, then it come out to be 0. And you can use this property to find out the two vectors are basically are parallel or not. To check it out they are parallel or not, just take the cross product between them, and cross product between them, and if you are checking that two vectors are perpendicular to each other, you should check the dot product, because then it is 0. It should be 0 if the two vectors are perpendicular to each other. And or the orthonormal vector, what is the cross product between the orthonormal vector? Let's suppose I take the x cap, y cap, and z cap, and if I take the, if they are ortho, because they are all the orthonormals, if I take the cross product between them, let me take the cross product between them, it is nothing but cross product is, can you imagine, between them, the cross product between them is 0, because they simply they are the vectors having the same direction, then the sine theta become uh, 0, and then theta becomes 0, and then sine theta becomes 0 simply. And let me, if you have the x x cap cross y cap, yeah, y cross z cap, and then z vector cross x cap, then it is simply give the 1. Yes, because the sine theta become 90 degree, then obviously it become 1. Yes, 90 degree, yes, sine 90 degree is 1. Yes, and the sine theta value is uh, if I put the theta, then it will be 0. Yes, if the theta, just remember it, the remember it order, okay, because it is not equal. If I put the x cross y vector, it is nothing but the minus of, yes, minus of x cross y, then it value come out to be -1. Yes, just you have to remember the order is simple. Let me take x y z, x y z. If you take x cross y is z cap, and x z cap, and y cross z is positive x cap. Just remember, if they are cyclic, if the cycle is anti-clockwise, then it is positive. If the cycle is clockwise, then you are getting, then you will get, if you are doing x cross z cap, you are getting minus y cap. Remember this result also, so simple. And then the next, the relation between the scalar and the vector product, you have to just try to remember it. It is not of much use, but maybe in some of the exam they directly ask some question related to it, and it is nothing but a dot b the whole square. Vector product of the two vectors is distributive. It means simply a plus b, a vector plus b vector into c vector is nothing but cross product. Okay, just write the cross product between them. It is nothing but a vector cross c vector plus b vector cross c vector. Do not forget, if we are change the order of it, the a and c, you have to put the minus sign. But this problem do not lie in the dot product. Yeah. Analytical expression for the vector product. Let's suppose uh, I have the vector is equal to x1 x cap plus y1 y cap and z1 z cap, and then b vector, let me write as x2 x cap plus y2 y cap and z2 z cap. Then if you are finding out the a cross b vector, it is nothing but you have to take the x cap, y cap and z cap. Then you have to coefficient of x1 a1 vector, x1 x2 x1 y1 z1, and similarly x2 y2, coefficient of the b vector. And just you have to, what you have to do, just you have to do the this determinant. You have to solve this determinant, and then you will get the answer for the a cross b vector. And just look at, after the solving the determinant, your answer is getting is a vector quantity. Yes, that's very important. After the cross product, you will get the vector quantity, and do not forget the vector quantity, the resultant after doing the cross product, the vector quantity direction is given by right hand rule.